In this video, we're going to be looking at a test or exam type question for analytical geometry. So all the basics that we learned, we are now going to apply in a question like this. There's 5 questions that we're going to answer. And remember that let's say a question for analytical geometry is out of 20. It doesn't mean like 20 of those questions are going to be so hard. It's not like that. Of that 20, maybe 7 or 6 marks. It's really going to make you think. But the rest of it is going to be straightforward. Do you know your basics and can you do it accurately? And also keep in mind that sometimes what you worked out in one of the first questions, let's say in A, you might need that information, say in question, the third question or the fourth question. So just keep that in mind, how the questions follow on one another. All right, before we jump in, if you want a copy of the workbook with all these examples and you haven't gotten that yet, I will put a link to that in the description so then you can just create a nice physical copy for yourself with all these examples to refer back to. All right, let's jump in. Let's read carefully before we even look at the questions. I know students like looking at the questions and then only looking at the diagram and the description. Let's do it the other way around. So we've got point A. I always just double check that the coordinates that they gave me in the description is indicated on the diagram, because otherwise we have to go put that in. And then coordinate B is also given, and then we've got coordinate C. And interesting, we note there that we've got a missing Y value there. That's part of coordinate C, and we can definitely anticipate that they're going to make us find the value of T, definitely. All right, and they just give us that those are 3 points on the Cartesian plane. Great, we can see that. The coordinates are given. Good. Is there anything else that you notice as you look at this diagram? Well, I mean, it's not even a triangle or a shape. It's literally just 2 lines. What is important to note is that the 2 lines cut there by point B. I don't know, maybe we're going to use that. We can say that that angle B looks like a 90-degree angle, but we can't go by looks. If they didn't give us that that's 90 degree, we can't say, oh, it looks like 90, so it is 90. For question 8, it says calculate the length of AB. So they want the length of line segment AB. So let's use the distance formula. Let's use the distance formula because that will give me the distance between point A and B. So the distance between A and B, I have my distance formula, and we just need to substitute that in correctly. So I'm going to take my 2x values, and I'm going to subtract them. And then I am going to take my y values, and I'm going to subtract them. Okay, now we just need to simplify that. Inside my first bracket, what are we going to get? And inside the second, well, for the first one, we're going to get negative 6, and then we're going to get negative 8. And when we're going to square both of those, they will become positive. So 6 squared, that would be 36. And 8 squared, that would be 64. So therefore, under the square root, we'll get 100. And the square root of 100 is just equal to 10. So the length of that line segment AB is equal to 10 units. All right, let's look at question B. Calculate the gradient of AB. So same 2 points, but now we have to go calculate the gradient. You must be able to do that in your sleep. All right, so change in my 2 y values. There they are. Looking at coordinate A and B, and then change in my 2x values. That would give us negative 8 over negative 6. And that will give us, is it 4 over 3? Yeah, positive 4 over 3. And that is the gradient for line AB. If we look at C, I just copied over that diagram again that we don't have to keep scrolling up and down and up and down. So for C, it says that if ABC is 90 degrees, find the value of T. So they are telling us, okay, if you've got that angle B is equal to 90 degrees, so I'm just going to put that in there. If that is 90-degree angle, find T. Okay, how are we going to do that? Well, if I see 90 degrees, that makes me think perpendicular. So we've got two lines who form a 90-degree angle. So they are perpendicular lines. And the moment that we start talking about the perpendicular lines, we need to remember this idea that the gradient of the one times the gradient of the other would give us -1. That will hold true if they are perpendicular. Well, they are telling us that that is 90, so it must be perpendicular. So we must be able to use that equation to find t. So let's go substitute that in. Well, the gradient of the first line, AB, we just calculated that in question B. See how they follow on one another. And that gradient was 4/3. So the gradient of AB times the gradient of BC will give us equal to -1. So this is applying our knowledge on perpendicular lines. The gradient of AB is 4/3. We don't know what this gradient is. That's what we're trying to find. But we know that it must give us -1. So I remember when we did the examples on perpendicular lines, we literally did that using 3 different ways. So however you go about finding that one, that is perfectly fine. What I'm going to do, I think I am going to divide this side by 4/3 so that they cancel out and I've got my m by itself. But what I do on the one side, I must just do the same on the other side. So then I've got my m by itself, and then my m would be equal to -3/4. So now we've got the gradient of this line BC, but that's not what they wanted from us. So it's not like we are done. How can we use that information to actually find that missing coordinate of t? Well, now that we've got the information of BC, we know that the gradient of BC, that's the gradient of BC, is also equal to the change in y over the change in x. All right, so that is if we were to calculate the gradient of BC. But we know the gradient of BC. We just figured it out by using the idea of perpendicular lines. So there it is. And that must be equal to t plus 5 over 1 plus 3, which will be 4. All right, so far so good. I'm running out of space a little bit. Let me just do that. I'm going to carry on over there. Now that is just equations with some fractions that we need to sort out. What I'm going to do, grade 10s, is I'm just going to multiply both sides by 4. And those denominators that are already the same makes that quite easy, because then that happens. And then we are left on the left-hand side with a -3, and on the right-hand side we are left with t plus 5. So now to find t by itself, I'm just going to subtract 5 on both sides. And then I get that t is -8. Now, if we look at where t is on this Cartesian plane, I think that looks pretty good. The y must definitely have a negative value, and it must be a negative value that is smaller than -5. If I look at -5 will be there. And then, yeah, that looks reasonable to me. Okay, perfect. So we found that value of t. Let's look at the next one. Question D. Determine the coordinates of M, the midpoint of AC. The midpoint of AC. So A to C, there it is. They want us to find the point that is exactly in the middle there. So I'm going to use point C as 1 and -8. So there we go. And let's find that midpoint using the midpoint formula of AC. I'm going to plus my x values, 3 plus 1. I'm going to divide that by 2. And then I'm going to add my 2 y values. Sorry. And that would be 3 and then plus a -8. And no, let me just start over. I didn't like that. I wasn't focusing. So that was 3 plus 1 over 2, and then it will be 3 plus minus 8 over 2. There's my 2 points. Let's just simplify that a little bit. So that will be equal to 4 over 2, which would be equal to 2. And then that will become 3, take away 8. That would be negative 5 over 2. And there is our midpoint AC. So in the middle between A and C, it is where X is 2, which should be somewhere over there. And where Y is negative 5 over 2, which is just equal to negative 2.5. So if we find that, negative 5 is there, so 2.5 should be more or less in the middle. Yeah, so I think that looks pretty good. All right, so just using our basics of the midpoint formula. Last question, question E. If point D, I don't see a D, was plotted onto, okay, so we're forming a rectangle and creating another point D. So we've got A, B, C, D. So A, B, C, D. So if we kind of eyeball it, maybe D somewhere over there to form a nice rectangle there, something like that. Okay, determine the coordinates of D. So we are creating a new point D, and we don't have the X coordinate or the Y coordinate. So there's 2 missing variables. Okay. The word rectangle is key. So let's just put in a rectangle there and just look at some of the properties. If you look at a rectangle, we know that we've got 90-degree angles forming over there. So we've got 90 degrees there and there. So maybe we could consider using those perpendicular lines idea again. But then we're going to have to calculate gradients, which is fine. We've worked out gradients in the previous questions, but I think we're going to get stuck because we've got the 2 missing variables. We've got the X and the Y. So I don't think that's enough. I guess we can use we can use the distance formula, but again, we're going to have 2 missing variables in the distance formula. I think we need to try this. When we've got 2 missing variables in the coordinates, so therefore the X and the Y missing. Let's think about a rectangle quickly. There we've got the diagonals. Let's say this is A, B, C, D. What do we know about the diagonals? Well, the diagonals bisect each other. So it means that it cuts AC in half, and that midpoint also cuts BD in half. And all those lengths are the same. All the side lengths will be the same, but I think the key thing there is bisect, that it cuts it in half. Why am I saying that's important? Because the midpoint of BD, whatever it is, will also be the same as the midpoint of AC. The midpoint of AC is equal to the midpoint of BD. And what is good, with the previous question, we found the midpoint of AC. The midpoint of AC. What was it again? 2 and negative 5 over 2. So we already have the midpoint of AC. So we've got that one already as 2 and negative 5 over 2. But if we put in this diagonal where we are creating that point D, it means that they share that midpoint. It is also the midpoint of BD. So how would we normally calculate the midpoint of BD? We would take the 2x values, we would add them, and we divide it by 2. Why is it x minus 3? Because we are adding a number that's already negative. My b value has a negative x coordinate. And then it will be y, take away 5, same reason. Okay, that will give us the midpoint of BD, but those are the 2 missing things that we found. What information do we have? We already have the midpoint of BD because it is the same as the midpoint of AC. What is the important knowledge that we need to apply there? The properties of a rectangle where they would share the midpoint. The diagonals bisect each other. So that would be equal to that. And refer back to the video on midpoints on how we do this to use this backwards or in reverse. Since these coordinates are equal to each other, it means that the x coordinate and the x coordinate of the two coordinates must be equal to each other. So that means the 2 must be equal to x minus 3 over 2. And it also means that that y value of the one coordinate must be equal to the y value of that coordinate because these coordinates are equal to each other. So that will be equal to that. It's so important that you're able to set this up like that. Okay, now we've got equations that we need to solve. I think what I'm going to do is I'm just going to multiply by 2 that side. Why am I doing that? Because then that will cancel out. But as long as I do the exact same thing on the other side, I'm good. So that's 4 is equal to, and on the right-hand side, we've got that left. So then if I add 3 on both sides, I get that my x is 7. So at this stage, we know that coordinate D has an x value of 7, but we still need to figure out the y. So let's go do that. With this one, equations with fractions, not just one way of doing this, but I'm going to multiply both sides by 2, y2, because then that cancels out with that. And now we've got negative 5 left on the left, and on the right we are left with y minus 5. So to get y by itself, I'm just going to plus 5 on both sides. So then I've got negative 5 plus 5, which is 0. So that means that coordinate D has an x value of 7 and a y value of 0. And that's coordinate D. So let's see if that makes sense. Well, I estimated that would be there, and I was a little bit off. It is actually where x is 7, somewhere there, and our y is 0. So on the line there. And there is our rectangle ABCD forming. If you figured this out using a different way, leave a comment and let me know. I would like to see and also try it out. And okay, let's head over to the next application question.